Hey guys, welcome back to the channel. In this video, we're going to be talking about series from Cambridge Additional Mathematics, IGCSE. And in this topic, we're going to learn quite a lot. So we're going to be starting off with the binomial theorem. In this, we can use two methods, which is like the Pascal, triangle, and also like using combinations. We're going to start with that, and then we also go into geometric progression, arithmetic progression, converging series. So there's a lot to unpack here, so stay tuned. Okay, so first of all, we're going to start with Pascal's triangle. Before we go into what it is, I just want to give you like an overview of why it's being used here. So when you want to expand something like x plus 1 whole squared, what do? You do x plus 1 multiplied by x plus 1, right? And then you multiply the terms and then you try to add the like terms. You could probably do it till like to the power of 3, power of 4. But after that it becomes really tedious. So you can't really do so many, you can't be like x plus 1 to the power of 100. How do you do that? You would have to multiply x plus 1 by itself 100 times. Just imagine how much time it would take. To solve this problem, mathematicians came up with something called as the Pascal's triangle or the binomial theorem. Pascal's triangle is an aid for binomial theorem. So I hope you've understood why we use this, and let's actually talk about how do you use this. So first, I'm going to tell you like how to draw the Pascal's triangle. So first you have to write 1 and 1. It looks like a triangle, so that's why it's called the Pascal's triangle. So you write 1 and 1. And now here you can see 1, right? And this is considered 0. So you have to add 2 of these numbers to get the third value. Just like that here. This is 0, so it's going to be 1. And then from here, you add these two numbers to get this. Add these two to get this number. So you keep doing that like as much as you want. But this method is also not very efficient. Let's say you want to find x plus 2 whole to the power of 100. You'd have to write this like 100 times. Not 100 times, it's going to be like 100 plus 99 plus 98 plus 97. So many numbers you'll have to write. So that's also not very efficient. But if you're trying to use this for like small numbers, like to the power of 6 or to the power of 7, it would be efficient. So therefore we use this. So I hope you've understood like how to derive the triangle. And now we're going to talk about how you actually use it. So when writing expansions of a plus b to the power of n out in order, you have to write it in this manner. So if it's to the power of 1, you put the coefficient, multiply that by the first term, and then again 1, b. And then you keep doing it that. So you can see the pattern, right? 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 6, 1, 4, 6, 4, 1. So you keep doing that. And here the term is 4, 3, 2, 1, 0. The power of the first element in the brackets, it will keep going down. The number will keep going down. It will be like 4, 3, 2, 1, 0. So whatever the power is, you have to multiply it here also. And then you keep going down until it's 0. But then for the second element, you have to stop with 0 and go on till this number. It's that simple. You just have to use the triangle and use like the ascending and descending order for like the first and second element respectively. And then that's it. You get the answer. So it's that simple. Now let's just look at this also so that you're clear. I'm going to cover this so you can like, actually no, that's not required, but anyways, we'll talk about this. So the first element will be 1, like the coefficient will be 1, and then multiply a to the power of 3 and b to the power of 0. You can write it out at the start so you don't get confused. And then the next number in the Pascal's triangle is 3. So you write 3 and then subtract 1 from this and add 1 to 0. So you get a squared b, and then keep doing that until you get only this term. And that's how you do it. And some of the things you have to keep in mind is that each row always starts and finishes with 1. There can't be any other number other than 1. And also, each number is the sum of two numbers in the row above it. So you can think of this as like a small triangle inside of the big triangle. So it's going to be the inverted triangle inside the big triangle. That's how you can remember it. And yeah, so that's how you do it. And the pattern keeps repeating. We have x plus 1 plus x to the power of 3. Like we discussed before, we have to use the Pascal's triangle. So we have 1, 1, 1, 2, 1, 1, 3, 3, 1. And therefore, we use this row, the third row to solve this. First, let's write this down. This is 1 to the power of 3 into 1 plus the coefficient will be 3 multiplied by 1 to the power of 2 x to the power of 1 plus 3 multiplied by 1 to the power of 1 multiplied by x squared plus 1 into x to the power of 3. We get 1 plus 3x plus 3x squared plus x cubed. So this is how you do it. With practice, you'll be good. And now let's try to solve this also. Let's use the same Pascal's triangle. So this is 1, 4, 6, 4, 1. I'm just going to rewrite this here. So 1, 4, 6, 4, 1. This is going to be 1 multiplied by 2x to the power of 4 plus 4 multiplied by 2x to the power of 3 multiplied by 5 plus 6 into 2x to the power of 2 multiplied by 5 squared plus 4 multiplied by 2x into 5 to the power of 3 plus 1 multiplied by 5 to the power of 4. Let's plug these values into a calculator to find the answer. So this is going to be 2 to the power of 4 is 16. So 16x to the power of 4 plus 4 into 2 to the power of 3 multiplied by 5. That's 160 x cubed plus 6 multiplied by 2 squared into 5 squared. That's 600 x squared plus 4 into 2 into 5 to the power of 3. That's 1000. That's 1000x, and then 5 to the power of 4 is 625. So that's the final answer. This is also going to be 1, 4, 6, 4, 1. So the first term is 2x to the power of 4 plus 4 multiplied by 2x to the power of 3 multiplied by y plus 6 multiplied by 2x to the power of 2 multiplied by y squared plus 4 multiplied by 2x multiplied by y cubed plus y cubed, y to the power of 4. This will give us 16x to the power of 4 plus 4 into 2 to the power of 3 is 32 x cubed y, and then 6 into 4 is 24. 24 x squared y squared plus 4 into 2, which is 8. 8x y cubed plus y to the power of 4. This is the final answer. For this one, we use 1, 3, 3, 1. This is y cubed plus 3 multiplied by y squared into 4 plus 3 into y multiplied by 4 squared plus 4 to the power of 3. This is y cubed plus 12y squared plus 48y plus 64. This is the final answer. And with that, we're done with all of these questions.